So, the talk of today is in continuation of what you talked about last week. I hope I don't overlap too much, but I wanted to talk about EventBridge. It's one of my favorite services from AWS, and it's always nice to make presentations out of it. First, I want to give a short introduction. I was already introduced, so you don't need to know much. Then I'm a developer advocate for AWS. I joined 7 months ago, so I'm quite new in this role. I'm based in Finland. I'm originally from Uruguay, so it's kind of an interesting mix. I've been coding all my life, so I'm a developer by heart, even if I'm doing this role that I don't have to code all the time, but I love coding and I love solving problems. So for me, architecture and solving problems and coding is my passion. And I have a YouTube channel where I post 2 or 3 times a video every week, 3 times a week, 2 times a week, depending on how my week is going, about serverless, cloud computing, and things like that. So you can find it in my YouTube channel. So go and subscribe. Most of my videos are really hands-on, so you can get the code from GitHub and learn different things. I just finished today posting a series on 5 videos on building serverless analytics pipelines. So I think it's quite interesting. So let's go to the talk of the day, and I wanted to start with an example that I think nowadays, because we live in this locked at home, we are using as much as we can. That is maybe delivery. I don't know how it's in your countries, but in my country, restaurants are closed, but they can do delivery, and I've been using all these apps so much, Uber Eats, Deliveroo, and I think they're a great example of an event-driven architecture. You have this app that gets all the orders from different customers, and then they send them through some system to the restaurant so the chefs can prepare the food, and then you get some person in a bike or in a car delivering that food to your house. So there is a lot of events moving back and forward from the different, from the restaurants and from the kind of service that is handling all these orders. So for example, we can have some little drawing like this. I'm very good at making drawings. and we have the cowboy there is the person doing the order, because we all love cowboy hats. And it's making the order through this service, Uber Eats, Deliveroo, Foodora, whatever is available where you live. And that then is sending a message to the restaurant with the right order. So basically, this service can contact the restaurant in multiple ways, or they can talk to each other. One way is the restaurant will come every 5 minutes, 1 minute, I don't know, 1 hour, and poke this aggregator service. Hey, do you have an order for me? And this is not really efficient. This is quite horrible in the sense that you need to build an integration there. Then if you poke too often, a lot of these requests will come with no answer, because customers are not doing a request all the time. Or then if you poke not too frequent, then customers may be waiting for half an hour to an order to get processed. So maybe this is not the right solution. Maybe we can look at the other way around, that the restaurant has some endpoint that the order aggregator service can poke. But then here we end up in the situation that multiple restaurants might have, are working with different order aggregator service, like Foodora, another one with Wolt. And then you have all these incoming connections from different producers of these events, and this becomes extremely highly coupled. You will have maybe different endpoints that the restaurant needs to have to handle different of these aggregator service, or then the aggregator service might need to do like code integration against these restaurants. So it becomes a mess, and we don't want to do that. Another option is just simply to send a message and then forget about it, not have a connection in anyhow. And this way, the aggregator service can do its job and the restaurant can do its job and communicate via messages that are more standard and generic. And if something happens in the restaurant, the aggregator service doesn't fail or doesn't get errors. So in that way, we are building an event-driven architecture. And we will have some benefits on doing that, not only in the restaurant example, but in more real life examples that we might build in our companies. Like if you are working in a company and every team is working on their microservices and you connect them using this event-driven architecture, then all the parts of your application can scale differently. And the other parts of your application don't need to scale and don't need to care about it. And the same with failures. If one part of your application fails, then the other part doesn't get affected, because if you have permanent connections, then if something fails, it can trigger a waterfall of failures everywhere that you don't even imagine. Another thing that you get from doing these kind of event-driven architectures is that you can do development with agility. If every team will have is connecting to other services via events, then they can deploy independently. They don't need to wait for somebody to deploy because the API is not ready. You just deploy whenever you're ready and you send events, and that's it. So that improves the resiliency of the application, improves that there is the parts of the applications are loosely coupled and the teams can work independently and faster. One benefit that I think maybe many of you have not thought about when working with event-driven architectures is that you get a log of all the events. So if you store those events that are flying inside your application, then you will have a log of everything that happens in your application. So if you need to do an audit, or you need to you have a problem with some data source and you want to replay everything, you can do that from the logs that you have saved. So that's very, very simple to do when you're doing an event-driven architecture. And finally, if you are using these event-driven architectures, you can take advantage of services like Lambda that is invoked whenever it's needed, and you don't need to pay for idle. So you might be able to cut some costs in your applications. So one thing that you need to do in order to create an event-driven architecture is to pick a router. And you might be wondering why I need a router. Well, if you have a consumer and you have a producer, they can connect, as we saw in the restaurant example. But here we might end up in a big mess if we don't have a router. Now we have two producers and two consumers, and they are both connected together, and the amount of links is growing, not linearly, with the amount of producers and consumers we have. Everything is extremely coupled. A new consumer comes, and then we need to register to all the producers. A new consumer goes, and then we need to remove it for all the producers. Everything is so tangled together that this is an architecture that you don't want to be involved with. It's very painful to manage. What you will need at the end of the day is something like this. This is cleaner, and this is way easier to manage. It will help you to maintain your code, and also when a new producer comes in, it doesn't need to register with the consumers, and when a new consumer comes in, the producer doesn't need to know about it, and everything is loosely coupled. And you might be thinking, this looks nice, but this event router is a nice bottleneck in my application. And I would say, yes, that's true in the past, when we were building applications on data centers, and you have this event router being one machine, that it was very hard to scale, because then you needed to manage the routing of the events and things like that. But in the world of cloud, and in the world of managed services, this event router is not a bottleneck. It's a service, distributed service, running in the cloud, in multiple availability zones, with all the resiliency in place to not be a bottleneck. It scales, and it can scale massively, so it's not a problem for you to worry at when you have this service in the middle. Because sometimes we think about load balancers. Well, that's kind of a bottleneck. No, this is not, and that's not something you need to worry about. For solving this problem, AWS last July launched EventBridge. This is a service that is focusing on solving the problem of building event-driven architectures to help you out and to make it very easily. EventBridge is a fully managed service. You pay as you go, and it has native integrations with multiple SaaS providers. It has integrations with most of the AWS services, and it has and you can create custom applications as well that sends events through EventBridge. And then in the other side, we have 17 target services. Maybe there are more now because these always keep on changing, that can be triggered when a new event comes. So this is a very flexible service, and basically it takes care of routing all your events. So how it works? From one side, we have the event source. We have the different AWS services, S3, logs, I don't know, Lambda, whatever. And this event source can be like a new object has been added in a bucket, or a new row has been added in Dynamo, or things like that. Things that happen in different AWS services. Then we have, as an event source, different SaaS applications. It can be Datadog, Zendesk, Mongo Atlas, Auth0. There is multiple of that. And they can be messages like, you have a new ticket in your Zendesk, or there is a negative review in your Zendesk. Can go very granular. Or you have a new user to log in your Auth0, or something happened in your MongoDB application. So you can go to very granular things, and that's a great way to integrate with a lot of SaaS applications that before we were using webhooks, for example, to see what was going on there, and we needed to build pieces of code that was handling that connection, and we have to take care of those connections, and creating code always add a lot of pain for the cost of ownership, and we want to avoid that as much as possible. And this is a native integration inside AWS. It's very simple, and all these services have built their part in order to integrate with EventBridge. And finally, we have the custom applications, and that's applications that you build, that you code, that are hosted in your AWS accounts that are sending events to EventBridge. They can be using the AWS SDK, for example. I will show you an example on how to do that. Or you can use tools like Lambda Destinations. I will not show you an example of that, but I have a video on my YouTube channel on how to do that if you want. But Lambda Destinations, basically what they do is you don't even need to use the SDK, the AWS SDK, to send an event, because it's configured in the infrastructure side of your Lambda function. And if, for example, the Lambda succeed, it will send an event to EventBridge, or if the Lambda fail, it will send an event to EventBridge. And in that way, you can create very interesting applications. So this is a very powerful piece of software. And then in the other side, we have the targets. And the targets are different AWS services that get triggered whenever an event comes. Typical examples, Lambda function. A Lambda gets triggered when a new event is in EventBridge. Kinesis Data Firehose, a new event arrives and Firehose puts it in a bucket to collect and analyze it. Step function, a step function is trigger when a new event comes, and it triggers a whole workflow. Queues, notifications, there are 17 of these, so there's quite many places that you can send events to. And finally, we have in the middle the event bus, and the event bus is made of rules. So there is as many rules as you can imagine, and these rules can be something very simple, like all the events coming from S3, to something very granular that you will like filter from the payload of your event. The rule can read very into the details of the event, and I will show you some examples of that in the demo. So how it goes, all the rules are connected to different targets, one or more, and if a rule gets enabled because the event matches the rule, then the message will go to the target. So the event source sent an event, and then the event will go to all the rules to get evaluated. Some of the rules will be like, yes, this matches my pattern, and then those will be sending the events to the target. And then things will happen depending on the target. Now you might be thinking, in AWS there's many other event routers, and I will tell you, yes, there are. But EventBridge is designed for helping you in building event-driven applications, so it might be the right choice most of the time. But in some cases it might not be. And I'll give you a receipt that, yes, this is the right and this is not. But I can give you some what you can think when you are deciding what event router to choose for your application. One thing that you can look for is the operational responsibility. EventBridge is a fully managed service, so it comes with the limitations of a fully managed service. You don't have much power to configure a lot of things, but you come with the flexibility that you have less responsibility in your hands. Everything is handled by AWS. But maybe you need very particular things that you need to use a Kafka that is running inside an EC2 that you scale and you maintain because you need that particular configuration and that particular things in place. So that's something you might need to think how much personalization you need in the services, how different is your service that it cannot use something out of the box. My recommendation always, when we are thinking of serverless architectures, is to try to go with whatever comes out of the platform designed for solving that problem. We don't want to build things and maintain things unless we need it. The philosophy of serverless is to try to minimize the unnecessary work and to try to minimize the reinventing the wheel. We want to give the most value to our stakeholders, and that is in general, provided by using managed services. Another thing that you might want to consider when choosing a routing service is if you need ordering in your events. And this is something that EventBridge doesn't provide. EventBridge is no ordering. It cannot guarantee the orders of the events. So when you're choosing that, you might need to think, does my application need events come in order? If you're building a router for a legacy application, maybe you don't have an option because you don't want to go inside the code and change it. But if you're building something that is new, that is greenfield, and you think that you need your events to come in order, I will tell you, reconsider that. You might not want to go that road. Making an application that needs order events, make it more fragile and less resilient. There is many patterns around that you can read and explore on how you can make applications more resilient by taking non-ordering events and handling that the events are not coming in order. So that's something that I recommend if people are building something from scratch. One thing I like from EventBridge is the amazing capability of integration. So we have talked about the event producers that talk to EventBridge in a very simple way. We also have talked about the targets that can receive the events from EventBridge in a very simple way. But there is two more integrations that I think they are pretty cool. The first one is the integration with CloudWatch logs that you can enable, and it will store all the events from some particular application or pattern into CloudWatch logs. Then you can use to audit your application, or you can replay them, or you have them there as a backup or as an audit place, depending on what you need. And also it has an integration with Kinesis Firehose that I think is pretty cool for doing ad hoc analysis on the events. So you can store them in a S3 bucket, and then because they're JSON, you can use Athena to run queries and maybe create visualizations and dashboards on the events, and that's almost real time. So it's pretty powerful what you can do with those events. So now the next question that you might have, how many event buses do we need? In EventBridge, there is 3 types of event buses. The first one is the default, where all the AWS services will send the events. Then we have the custom, that applications can send the event through. You can, I think, have 5 or 6 or something like that per account. I don't know if it have changed, but it's enough number for your applications to send event. And then you have the partner event buses. And these buses are independent from each other. They will not share the information, and the different targets will not be able to see the events are coming from one or the other if they are not connected. So they're totally isolated. You can have something like one bus for everything, because the default event bus can take also messages from your custom applications and AWS. And I tend to go through this road quite often because it's the simplest one. Another option is that every application has a custom event bus, and then you have a default bus for your AWS applications. What I don't recommend to do is to have so many event buses that then the routing needs to be done in the producer. This is a very dangerous thing to do, because here we are ignoring, doing all the wrong things, because now the producer needs to write event bus that will not do any routing, because you might have one per consumer, and this is something that you need to avoid. Not adding routing logic in the producer at all. Avoid that at all costs. You don't want to have that in place. One other option, if you have data going through your bus that might be sensitive and you don't want it to get mixed with other services, is to have a domain alignment through your buses that, well, this bus is for the orders, this bus is for administration, and then all the data inside those buses is encrypted and the targets cannot see it, and it's kind of isolated one bus from the other. This is a great way to make your application isolated from each other if you need, and decouple. One thing I like a lot is that you can provision the event bus separately from the rules. So this is an example of 3 different CloudFormation stacks that we have here. The first one is the shared services, where we will have, I don't know, the CloudWatch alarms, the event bus, shared bus, the whatever logs, and the firehose, all these things that can with the event bus. And then in 2 different stacks, we will have 2 different consumers. And the neat thing here is that the rules are defined in the consumer stack, because in general, the rules are very close related with the consumer. Like the rule might say, I don't know, if the restaurant name is this, in the event, trigger this lambda. And you don't want to have that in the shared service, because every time, for example, you add a restaurant, you might need to modify the shared service. So you want to separate that. So whenever you add a restaurant, you create a rule, and then you create the logic to support that. I will show you an example on how this is deployed with some templates. Another thing you can do with EventBridge that I like pretty much, because this makes it very powerful, is have cross-account events. So here we have 3 different AWS accounts, and you have the producer is in one account, the consumers are in different accounts, and how you can do this? Well, very simple. You create a local bus in front of each of the consumers, basically the door of the AWS account, and that will be taking the events from the producer. But if we leave it like this, this is breaking that rule that I told you, that the producer cannot route events into the event buses, because here the producer will need to do some kind of routing into the different accounts, and we don't want that. We want to not have routing logic inside of our producer. So what we will do is we will add a local event bus in front of the producer that will be routing according to rules to the different AWS accounts to other event buses. And you can send these messages through accounts, cross accounts, it's no problem. Another thing that is quite interesting is how you can structure your events. And this is something that you need to think. Again, there is no right or wrong answer. It depends on the service that you're building. And even inside the same service or the same microservice or whatever you're building, you might have different solutions for one case or another. So you have events that are like very concrete and say the order was created by customer. So just the basic information that the service receiving the event can utilize to continue, and maybe they need to come back to, I don't know, the order service to get more information on the order, but that's something that is fine. And then you have these other type of events that have the full state description that says this order was created, the amount was this, the items was blah, very verbose event. So when to use one or the other? If you use the full state description, it can happen that the service that is using the information gets information that is out of date. So maybe in the cases of orders, that doesn't happen because the order is made once and then is processed. But in the cases of other things that are more are changing all the time, maybe it can affect, and the service that is handling that event might have incorrect data. In the case of events that are very minimal, I have just the basic information. What can happen is that a lot of services can come and bombard some service that is, for example, providing the order detail because they might need it to move forward. So here you need to do a balance on how much information you provide in the event so the different services can move on with their work, and how much you are expecting requests from other services asking you for more information and how your services scale. So this is something just for thoughts, and neither one is perfect. One thing I want to share now is the anatomy of an event. So this is a JSON object that EventBridge is going to receive. This event is sent by your custom applications, by, I don't know, SaaS providers, AWS services, and it always have more or less the same structure. It has two parts: the envelope metadata, that's kind of the same for all the events. And then we have the payload, and the payload is just a valid JSON with information that, for example, if you're building your custom application, you can really do whatever you want with the payload. So in the envelope metadata, we will have first the managed attributes. These are attributes like the ID of the event, the account that created this event, the vision, and information like that. Then we have a timestamp that to have. If you want to order your event somewhere, I don't know, you can use a timestamp. Then we have the source of the event, that is the service that created the event. Then we have the detail type, that is some kind of a static schema on that event. So I will show you an example on how to build an event in a second, but this is something that is quite handy. Sometimes your service might be, for example, the order service, and the detail type is create a new order, and you might have another one that is get the order type or update the order or something like that. Then you have resources that are identifiers impacted by the event. I never used that, but maybe somebody did. And then you have the payload, that is basically any valid JSON. And the cool thing is that the rules can read through the whole event. So if you put information in the payload, it's accessible for the rules to read and access it. So one last thing before we go to the demo is how you manage event types. So you might have custom applications, AWS services, SaaS providers, all sending events through EventBridge, and how you handle all this amount of events. In general, a lot of companies are using EventBridge as a way to communicate through multiple teams, and one thing that happens is that events change with time, or the documentation provided by the different teams that are building that event are not great. So in last event, AWS launched a new feature for EventBridge that I think is really cool, that is called the Schema Registry and Discovery. And the Schema Registry basically has a list of all the events from AWS. So now you don't need to guess what event is coming when S3 is calling you. Then it also have the SaaS providers definitions for the event. And also, if you have custom applications sending events, they will appear there as well. The events from custom applications, they don't appear automatically there. You need to discover them. And that's another feature that is available from EventBridge. You can enable the discovery feature, and that will start collecting all the events that goes through the event bus. And that's pretty cool. It's something I recommend to do in development, not to have it in production, because it's not a cheap thing to have on. But then when you discover the events, then you can download the bindings for Java, Python, TypeScript, or you at least can see the event definition. There is multiple integration in the Schema Registry for Visual Studio Code and JetBrains as well, so you can play with those events that are in the registry. So when you capture the events with discovery, then you can stop the discovery, and all the events that you capture will be appearing in your registry. I will show you in a second. So how this is priced: the registry is free. It's a feature of EventBridge, so it's there. And the discovery has some cost. In the free tier, you have 5 million ingested events per month. So that's why I recommend that you turn it on for development, and then you turn it off you don't need it as after you find the events that you want, or if you have some doubt that some event changed, you can enable it. But I don't know. Customers always find interesting use cases. Maybe some people keep it on all the time because they do some cool stuff. So if you're one of those, let me know. I'm interested in knowing. So now we are ready to move to the demo. So I want to show the code. But first, I will show you a little bit of the architecture of the application I'm building. I'm built already, so it's there. So it's 3 stacks. We have the order manager, that is our kind of the one that is getting all the orders. So we are building this kind of restaurant app. So this one is getting all the orders, and I forgot to add in the drawing an API gateway, but basically an API gateway is triggering a Lambda, is getting the orders from the API gateway, and that Lambda is sending an event to EventBridge. Then we have an EventBridge with 3 rules. 1 in each of the stacks. 1 rule in the order manager stack, that is the one, if the restaurant doesn't exist, it will trigger Lambda to just say that the restaurant doesn't exist. I didn't invest much time on making this Lambda, so the code is very raw. And then we have these 2 other rules that are depending if the order comes to one particular restaurant, will trigger the Lambda that comes next. So I will switch to Visual Studio Code and show you the code. I don't know if you're seeing my screen. Are you? Let's see. I never understand Chime, and I work with this thing. Let's see. Can you see my screen? My Visual Studio Code.
We can see the slide. We could see VS Code just beforehand.
Okay, now?
Not at the moment, no.
Okay, let's try again. Ooh. I always get confused with Chime, so sorry. Can you see Visual Studio Code now?
We can, yeah.
Yay! So here I have 3 different folders. Each of them contains some applications. So the order manager is the one that contains these 2 lambdas, and then the API gateway. So if I go to the template YAML, here I will see the API gateway definition, the function that puts the order in the system, and then the function that is taking care of this not valid restaurant. So let's look at this function. And this function basically is a simple function. It's triggered by an API gateway. And the only thing that it has in the definition that is strange is permissions to put events in EventBridge. So then we can check the handler. That is, I think, maybe the most interesting part. The code is so simple that it's it's hard to show. But we have this function that is put the order. That is the one that is called whenever the function is triggered. And basically this gets from the HTTP event, the request that is coming, it gets the body. And in that body, I will have some basic definition of the order that the person is making, what they are ordering, to what restaurant, how much money they are paying. And then I will call this other function that is basically putting the event in EventBridge. So here in this detail, I'm just constructing the payload. I'm not doing anything than just one-to-one. It's just super simple. And then in these params, I'm building the event. So I could put multiple events, but I'm just putting one. In the events, we have the payload that is defined as detail. And then we have the detail type. And this is what I was saying when I was talking about the event definitions, that you can have the source is the service name. So in this case, custom.orderManager, that's the name of my source. And the detail type can be new order or whatever you want, but it's something more detailed. And here I could have multiple functions sending events to EventBridge, and that's why I might want to have more detail in the detail type. And then after I build this kind of event envelope and payload, I will just put events and send that to EventBridge. And that's it. There is no more code. And then what will happen is that either one or the other restaurant or the non-found lambda will get triggered. I will show you now the template for one of the restaurants. I have implemented the trigger of the lambda functions in both of the restaurants differently, just to give you an idea on how you can do it. So the Pizza Hut restaurant, when the event comes to EventBridge, it will we need to define the rule, because this is defined in the stack of the restaurants I show you in the diagram. So in here we will have the function. The function is extremely simple. It doesn't have even an event trigger. And then it has the rule definition as CloudFormation. And then it has the permissions that the rule needs to invoke the lambda. So here we are defining the function as sum, using the sum template, and then the rule and the permission as CloudFormation. So if we go to the rule, that is this one, it's very straightforward. We have an event rule, and then you will have event pattern. And this is where the rule needs to match the pattern. So an event comes, and then the rule will check, okay, is this event matching this pattern that I gave when I was defined? In this case, the source needs to match, the detail type needs to match, and also the restaurant name needs to match. And this is coming from the payload of my message. So this is something that is very exclusive for my message in particular. So it's pretty nice. And then we have to define for each rule the different targets. And in this case, I'm defining that the target is this function. In order to trigger a function, you need to give permissions for this rule to invoke the function. And you do that by just writing this. You need to give the permissions to invoke this function. And it will be EventBridge that will do it from this rule. And this is, I have to write here 35 lines of code. So if you're lazy, like I am, one other solution is to use this other way that I use in the Thailand restaurant. I'm very original with the names, I know. Where I wrote maybe 23 lines of code, and I think it's simpler. In this case, I'm using sum for everything. I'm using the function definition the same way. And then I'm defining the trigger of the event using sum as well. And here what I'm doing is putting that the type of the trigger is a CloudWatch event, because EventBridge is built on CloudWatch events, so that's the type. And then again, I'm creating the pattern here for the rule to match. So what this little sum opinionated piece of code will do, will create the function, will create the rule, and will create the permission for the rule to invoke this function. So everything is done in this little piece of code. And for me, this is way clearer and less hassle. So this is two ways of doing the same. And in the order manager, I have used the lazy way of creating the function. So you can see here that I have this other function where there is not a valid restaurant that you define the pattern that it needs to match. But here, in the other cases, I was writing the detail needs to restaurant name, exactly the name of the restaurant. But here I'm using this anything but. And here I can put a list of things. And this pattern matching is something that is very powerful. I have the demo here. And I recommend you to take a look at this URL, where there is all the information you need to know about pattern matching, because it's extremely powerful what you can do when it comes to do the pattern matching for the rules. So let's go to the AWS console now, and let's check what I have deployed. So I have deployed this, and I will be seeing this in my event buses. I only have one event bus, that is the default. I'm not creating any new event bus. And here you have the start discovery. So if you want to start getting events and start discovering them, you just enable this. And whenever a new event is sent, it will appear in your schema registry, in your schemas. Here you have all the events from AWS, and here you will have all the Discover schema registries. So here is, for example, the event that I've been sending around is defined here. So you can see the event definition that is coming inside EventBridge, and how it's coming, so you can then work with this. I will go back to my event bus and stop the discovery. Even if AWS is paying my bill, I don't want to take advantage of that. And then inside the event bus, you can see some information on the event bus, but you cannot see much because where the things are is in the rules. In the rules, you will be able to see all the rules for all the event buses. I only have one, so in here you can select which one you want to see. I only have this one. And then there are many rules that are things that you should not delete. But these last three are the ones that I just deployed: the not a valid restaurant, and the Pizza Hut, and the Thailand. So if I open a rule, then I will see the pattern matching, what the event needs to match against. In this case, the restaurant names doesn't need to be Pizza Hut or Thailand, and then it will execute this Lambda function that is defined in the target. So let's run a little demo. So I will go to the Lambda and open, I think, Pizza Hut, and let's look at the logs. So now I can go to Postman, and here I have an event that is sending a new order to my API gateway. That API gateway is sending it to Lambda. That Lambda is putting the event in the EventBridge, and then EventBridge is triggering the right restaurant. And here I'm putting the restaurant name to be Pizza Hut. So I will just put send, wait for it. If my internet works, I get a 200 back. So now in the logs, I should see a new log being created here. So let's wait for it. And now in here, that is the latest, I can see that Pizza Hut has received an order, and this is the event that it's been sent in the Lambda. When the Lambda gets triggered, there is this event object, and this is what is inside the event object. So you can see that is exactly the event that I have defined when I put the event in EventBridge. The ID, the detail type, the source, the account that sends the event, the time, the region, and then this is the payload, that is the name of the restaurant, the order, the name of the person that ordered it, and the amount. This is exactly what I just put in the body of the HTTP request. So, and the way that this works is very fast, so it just happens quite automatically when an event arrives, and it just triggers the Lambda very fast. So if you want to get the code, this is the link. I will share the slides with you. I will share the link for where you can get the slides, so you can get all these links there. But the code is basically, you can download it and deploy it into your AWS account, and it should not be a problem. So I'm open for questions, and yeah, I hope you have enjoyed this. And if you don't want to make the questions now, my Twitter DMs are always open, and I'm always happy to answer questions there, as well as in my YouTube channel. So yeah, I will stop sharing the screen so I can see if there is any question.